This is factoring lesson 4. We're going to be factoring differences of two squares and perfect square trinomials. So recall from an earlier lesson, the unit we did before this one, x minus 3 times x plus 3. What did we get here? We do x times x, which is x squared. X times 3 is 3x. Negative 3 times x is a negative 3x. Negative 3 times 3 is a negative 9. And what happened here were that these two middle terms always canceled out, and we were just off by a sign there. And we end up with x squared minus 9. Now we had mentioned that if we ever had something like x minus y times x plus y, that this was equal to x squared minus y squared. That wasn't hugely important, you knew it then, because it was just a consequence of what happened. But now it will be important that you can go, because now we're going to be given the x squared minus 9, and you just need to know that it's x minus 3, x plus 3. So the difference of squares is x squared minus y squared is x minus y times x plus y. Let's work through a handful of examples. So factor x squared minus 4. So this is going to be x minus 2 times x plus 2. We're basically taking the square root of both of these pieces right here. Now I'll be honest, factoring in the real world, you're not going to get a lot of it. But when you do see factoring in your other classes, whether it be biology or business, when I've tutored these classes, like in finance and in upper level biologies, they do like giving difference of squares. My theory is that it's not very difficult to do. Teachers there don't want to actually teach how to factor. These show up all the time, difference of squares. So make sure you can do these. How about x squared minus 9? We just saw this one. Be x minus 3, x plus 3. And we could certainly flip that around. X plus 3, x minus 3. X squared minus 25. X minus 5, x plus 5. For x squared minus 25. First one we've had with a number other than 1 beside the x squared, but what's this going to be? Square root of 4 is 2, so this is going to be 2x minus 5, 2x plus 5. Now you should be checking these, right? Do 2x times 2x, 4x squared, 2x times positive 5 plus 10x, and then minus 10x, and then minus 25. I recommend doing this in the first few just so you can really see why this works out the way you get 4x squared minus 25. Example 5, factor 18x squared minus 50. Well, wait a second, these aren't perfect squares. Now, they don't have to be perfect squares in order to factor them, but it's nice when they are because it comes out with nice integer values. What should I do first on this one? Our number one rule of factoring is to factor out a common factor. So number one rule, factor out a common factor. Common factor here is 2. So now I'm left with 9x squared minus 25. Now I can go to it. I can factor inside here. Don't forget your 2. You'll get 3x minus 5, 3x plus 5. If you're going to miss it, it's probably going to be forgetting to put that 2 there. Make sure you don't do that. 8x cubed minus 2x. Another one where you need to pull out a common factor. Give yourself a second to think about that. Pick 2x. Hope so. So 2x. And what am I left with? 4x squared minus 1. Then always look here to see if you can factor that. We can. It's going to be 2x minus 1. 2x plus 1. 64x squared minus 9 equals 0. So now we are actually trying to solve. Not sure what it says. Objectives, just another example. So we can factor this, 8x minus 3, 8x plus 3 equals 0. And it's the same properties we've had when solving equations before. Set it to 0, factor it, set each factor equal to 0, and then solve each of those for x. 8x equals 3, x equals 3/8. Subtract 3 from both sides, x equals negative 3/8. Sometimes this is written as x equals plus or minus 3/8. So just nice and compact. Math folks love things compact when they're off only by a sign. One's a positive, one's a negative. Factor x squared plus 16. Let me pause the video here, see if you can get this one. Okay, welcome back. What'd you get here? Most students miss this one. They'll say x minus 4 times x plus 4. But what happens when I multiply this out? I get x squared minus 16, which is not x squared plus 16. So then what they'll say is, I'll just put a plus here. But what happens if you just put a plus there? You'll get x squared plus 4x plus 4x plus 16. Do those terms cancel out? No. 4x plus 4x is 8x. X squared plus 8x plus 16, which is certainly not equal to that. So this one is prime. We cannot factor a sum of two squares over the real numbers. Okay, let's look at perfect square trinomials. Again, we saw these before. It's not crucial that you get this, but the end answer, I want you to be able to rewrite it as a perfect square. So x squared plus 10x plus 25. It's nice if you can recognize that these are perfect squares, and that the sum of those perfect squares doubled is the middle term. That's sometimes hard for students to do. It's hard for me to do. So what I'll do is I'll go ahead and factor this in the normal way. So it's going to be x plus 5, right? Because when I factor 25, 5 times 5 is 25, and 5 plus 5 is 7. Not sure what's happening to my letters here. Okay, so we're going to get x plus 5, but when this is repeated, go ahead and write it x plus 5 quantity squared. Nice and compact. And that is equal to that. X squared minus 14x plus 49. Pause the video here, see if you can get it. Alright, welcome back. So, I'm going to get x minus 7, x minus 7, right? Because we factor to 49, 7 and 7, and if they're both negative, we end up getting the sum of negative 14. So I can rewrite this as x minus 7 quantity squared. Okay, 2y squared minus 32y plus 128. Oh, we got a 2 here. A 2, we can pull out my common factor. Number one rule, right? Pull out the common factor. Y squared minus 16y plus 64. Factors of 64. We're going to get 8 and 8. Both of them negative. Don't forget your 2. So 2, we're going to get y minus 8 times y minus 8. We can skip a step, right? And just say squared. Example 11. So what do we have here? So again, factors here of 9. 3 times 3, so we can redo this by grouping. So 9 x squared plus 3x plus 3x plus 1. Now if you recognize this as a perfect square trinomial, you can go straight to the answer. I find it really difficult for students to do that right off the bat. So I'm going to recommend that you don't do that, and you just do factor the normal way. In the very end, write that. Now if you're going into a mathematical field, you want to be able to pick those patterns up. But that takes practice. It'll take when you do maybe 10 of these before you start seeing that. So I can pull out a 3x from the first group. I'll get 3x plus 1. Still have a 3x plus 1 in that group. And so I've got 3x plus 1. I can factor out. Then what am I left with? 3x plus 1. So I can rewrite this as 3x plus 1 squared. Again, if you're good, you can see this right from the beginning. You can see this is a perfect square, that's a perfect square. Square root of both of those. When I combine them together, add them together, and double it, boom, I get the middle term. You can go right there. That's hard to see. 25x squared plus 30x plus 9. Okay, again, if you recognize this as a perfect square, great. I'm going to show you how to do it without even knowing that. We just kind of go into our mode of factoring by grouping. So 25 times 9, 225. Now if you recognize that, yeah, it could be a perfect square. So the square root of 225 is 15. So 15 times 15, does that work out? Well, it sure does. So 25x squared plus 15x plus 15x plus 9, and then do your grouping. Pull out your 5x. You'll be left with 5x plus 3 plus, pull out 3. And you get 5x plus 3. So we get 5x plus 3 times another 5x plus 3, which is 5x plus 3 squared. Okay, solving equations just like we've done in the last few lessons. We can solve equations with this in exactly the same way. We'll just do a couple here. We'll factor that, x minus 2, x plus 2 is 0, set each factor equal to 0. And then solve for x. X equals 2, x equals negative 2. So it's a difference of squares, very similar with the one we just did, which was 5x plus 3 squared equals 0. So we factor it. We set each factor equals 0, but both these are the same factor. So we really just need to set one of these equal to 0. 5x plus 3 equals 0. Subtract 3, subtract 3. 5x equals negative 3, x equals a negative 3, this. Make that 3 look a little better, negative 3/5. We should be able to plug that negative 3/5 in for x, and it proves a true statement. Okay, another one, example 15. Again, we've already factored this before. This is x plus 5 squared equals 0. So I just set one of those. This is x plus 5 times x plus 5. Subtract 5, you get x equals negative 5. And that's it. So we are done with factoring. What becomes a challenge is when all of these are sort of mixed up into one. So not only difference of squares, perfect squares, but other types of trinomials, polynomials we have to factor. That gets tricky, so make sure you practice with them mixed up. Perhaps I'll give you a handout or some homework where they're all sort of jumbled together.